Hello everyone, my name is Jalen Darden, and today I'll walk you through a demonstration using one of Python's many tools. This tool is called Matplotlib, and it demonstrates the use of custom meaningful visualization. I chose it because it offers a level of flexibility that many beginner-friendly tools don't. Compared to typical point-and-click tools like Excel or Flourish, this tool allows complete control through code, which means I can explicitly decide what to show and how. Even though it's not as interactive by default, I wanted to challenge myself and show a static tool can still support many of the visualization principles that we discussed in this course. I also wanted a tool that's widely used in real-world data science and analytic roles. Python is practically everywhere, and Matplotlib is the foundation to that ecosystem. To keep the focus on the visuals, I designed a small data set myself. It spans 4 years from 2020 to 2023. It tracks fictional incident counts each year as categorized into a severity level from low, medium, or high. I added a third column, not for statistical complexity, but for visual encoding potential. That category column is what lets me demonstrate conditional styling, color encoding, and pre-attentive processing, which, as we learned, is critical to good visual storytelling. The first visualization is a line plot. This helps shows trends over time. I chose this chart because it supports a temporal task identifying whether incidences are increasing, decreasing, or remaining stable. The markers highlight individual data points, and I kept the background clean to follow Tufts' idea of maximizing data ink and removing chart jump. I also included a grid to assist with visual estimation, but made it subtle enough that it doesn't overpower the data. I also thought about exploring adding a rolling average or a forecasted trend line, but even with this very basic version, it communicates changes very clearly. The next chart that I'll be showing is a bar chart. The bar chart shows the same incidence count, but this time with color encoding applied. This is where the severity category really comes into play. By mapping low severity to green, medium to orange, and high to red, I'm applying pre-attentive visual features. The color carries meaning before the user even has to read the axis. This encoding also supports rapid comparison, especially if someone is scanning the chart quickly. I had to use a Python list comprehension to assign these colors based on values. That part wasn't too hard once I understood how to map logic into a visual variable. I also considered adding some tooltips or hover interactivity using things like Plotly or Seaborn. For this assignment, I decided to stick with the Matplotlib and simulate emphasis using color alone. If this were a exploratory dashboard, might have switched tools, but for clear presentation graphics, this approach works well. The next one I'll be showing is a scatter plot. For the scatter plot, I wanted to blend overview and detail. The layout gives a broad look at distribution, while the annotations provide exact values. Each point is intentionally spaced, sized, and styled. This helps avoid occlusion and lets the user zero in on specific years. Adding the labels with commands such as plot.text was a bit tricky at first. I had to tweak the vertical offset to avoid things like collisions with the points. But overall, this visualization supports a diagnostic task, identifying how extreme each year was compared to the others. If you were building a live dashboard, you'd probably use the scatter plot as a clickable element. But even without interactivity, it works well as a hybrid visual. So going over some merits of the Python, right? The biggest benefit of using Matplotlib is definitely its flexibility. Once I understood how to connect data to visuals, it felt like I could make the chart do whatever I wanted. Things like font size and padding, colors, and plot dimensions were all under my control. That level of customization let me apply course concepts exactly how I wanted, instead of relying on a tool's default settings. I appreciated the integration with Jupyter Notebooks. It was helpful to write comments next to the code and visualize step by step how the chart changed with each adjustment. That gave me a better understanding of visual mapping. It made me more confident working with code in a visual context. And finally, knowing that it's widely used in data science, I feel like I gained a practical skill that I can apply beyond this class. Here's an example of some of the code that was wrote. But then we have some shortcomings of Python, as I experienced. Despite all the strengths, I did hit some roadblocks. First, the layout management was a little bit frustrating. Getting things like spacing between subplots or label assignments to look just right took more time than I actually expected. I had to Google a lot of syntax, especially for saving figures with the right resolution or changing label formats. Another limitation was the interactivity. With wild tools like Tableau and Flourish, you can hover, click, and explore data dynamically. The Python tool doesn't do that out of the box. Everything is static. So while it's great for creating potential published graphics for a report or a slide deck, it wouldn't be my first choice for exploratory data analysis or live dashboards. To visually emphasize this difference, I created a side-by-side comparison. On the left is a basic version, gray bars, blue bars, default styling, no clear message. On the right, I applied data-driven encoding and different color logics. The second version communicates more, even though the data set didn't change. The visual contrast made me realize how thoughtful design choices can transform a simple chart into such persuasive narratives. To wrap this up, this tool presentation showed how Python's tool can be used to build expressive, theory-aligned visuals using a simple custom dataset. We explore line plots, color-encoded bar graphs, and annotated scatter plots, all designed with tough gestalt and pre-attentive principles in mind. While I faced some technical challenges, I gained a clearer understanding of how to map data to visual features, and now I feel better equipped to evaluate and build visualizations in both the academic and professional setting. Thanks again for watching. I look forward to my feedback.
Okay, thank you. Um, that's pretty much